All right, so I want to look at determining that best fitting or good fitting constant of proportionality or slope for our proportionality model, y equal kx. And so here I've put in some data, just some very simple data. I went 1, 2, 3, 4, 5, 6. And then what I wanted was something that I knew was going to have an answer around 2. And the way I did that was I simply went through and I said, well, 2 times 1 is 2. And so I used 1.8 instead. So I made it sort of noisy, scattered data. I didn't want it to be perfect because generally speaking, when we have real data, it's not. And so then 2 times 2 is 4. Well, I made that one a little big. So the 1.8 was a little small, 4.3 is a little big, 6.6 a little big, 7.2 is a little small, 8.9 is a little small because it should be 10, and then 12.2 is a little big. And so these data are more or less along the lines of a y equal 2x kind of relationship. But, you know, if I didn't know that, what I'd probably do is I'd go in here as we do in the project and I'd just type in y equal kx. I add that slider, and now you know, I know the answer is around 2, but of course the slider defaults to minus 10 and 10. And you know, and so suppose I didn't know the answer was 2. Well, I could still change these, and you can change the slider simply by clicking on either end of these. So if I click on that 10, it starts me out there, but notice there's nothing here either. If I don't put anything there, it'll put the minus 10 back. I'm going to put 0 since I know it's got to be positive. And then here I could leave the 10, but since I know it's 2, just so we can see things better, I'm going to use a 4. So now I can click on that slider and just move it back and forth. And so, you know, the 1 is definitely too small, and I can see that because it's below the data, and I know that as I make it bigger I get a steeper and steeper slope, but I'm always going to go through 0, 0 here, and so I know I need a bigger number here. So I start sliding it up, and 1.14, 1.37, those are all still too small, and I get kind of excited and I get up here at 2.8, 2.6. Those are too big because you see they're all above the data. So I come down here and I just look. I'm eyeballing, I'm not looking at the numbers, I'm looking at the blue line, and you know, I look there and I think that looks like a really good picture. I see that I have 3 points that are basically above the line. I have 3 points that are basically below. Now this one's kind of touching. Now the center, of course, isn't, but you know, with the drawing, it's kind of touching. But that one's really close, and that one's really close, and then these two are a little farther away. So now, if you were anal retentive, I don't know, you might say it even needs to go down just a little bit further. And now if you're not so great with that, you can always just if I go here and I put a 4 and hit enter, it changes it to a 4. So I can always just type in a number here, and as I look at that, maybe 1.94, maybe that looks a little better. We're just eyeballing it, and so as you write something up, well, how do you justify that 1.94 is the best answer, or at least, you know, a really good answer? Well, you show the picture, and that's why I have you add that screenshot in there. Is you want to show the picture, and that's going to be my justification. Now that all said, 1.94, that's almost 2, and remember I actually had stopped at 1.95. And so that's almost 2. Well, for a lot of reasons, I may want it to just be a 2. Wouldn't that be a much nicer number? Well, what I can do is I can go in here and say y equals 2x. and that did it in purple and as opposed to blue. I can sort of tell the difference. You know, the darker one right now, since I'm clicked in that cell, the purple is showing up a little more, and the blue is just below it down here. And of course, you can't tell the difference down near 0 because they both go through 0, 0. But as you move farther away from 0, 0, I can see the difference. Now, so the question is, if you really wanted it to be 2 instead of 1.95, you could use a picture like this to argue that, well, for various reasons, like 2 is a much easier number to work with than 1.95. Maybe I'm only trying to hit the broadside of a barn with a stone or something like that, and so in that case, maybe it just really doesn't matter that it's 2. It could be 1.95, 1.95 or 2. So let's leave it at 2. And here, this picture kind of justifies my argument that I'm really not suggesting a much different model when I go with 1.95 versus 2. And so let's go with 2. Sure, okay, that would be good enough justification. Now, if you just didn't say anything about it, now let me turn this off by clicking on that. So now our only line that's showing is the 2x. Now, if I were to look at this, I'd probably say that looks fine. But notice it definitely is a little more moved toward these points that are above it than the points below it. So one could argue, if they were definitely anal retentive, that 2x is not quite the right answer. But again, just show them both and say, well, I want to go with 2x. I'm making a conscious decision, and this is why. Oh, right answer. Okay? And that's the thing, I realize that with many students, this idea that, okay, will a 1.95 give me an A and a 2 give me a B? Well, actually, the 1.95 could give you a B or a C or an F if you don't tell me why you picked it. And again, a good way to tell me is to show me the picture and talk about it. But you see, if you just say, well, it's 1.95, but give me no reason, well, then it's wrong. I mean, if you don't have a reason for what you're saying, it's wrong. And so, in that way, if you said it's y equal 2x and you show me this picture, well, I'll probably go with it. Sure, that's 2x. Now, to be even more complete, what you'd really like to say is, well, actually 1.95 fits it a little better, but 2 fits it good enough, and as you look at this picture, that's how I tell you it's good enough. I don't see a real difference here. Now, there are times when it can matter. Again, I say if the context is we're just trying to hit the broadside of a barn, then okay, did I hit the barn in the middle or did I hit it toward one side or something like that? Who cares? I hit the barn. So 2x is fine. However, there are other things where it could matter a lot. And so since 2 is bigger than 1.95, I'll go with something like chemotherapy drugs. Okay, when a person uses chemotherapy, basically what we're doing is poisoning their body. And the poison goes after the fast developing cells like cancer much quicker than it goes after the slow developing cells, and that's how chemotherapy works. And so in the end, right, if I'm going to get chemotherapy, I would like the least amount of chemotherapy I can get that will still work. Well, suppose that in some simple relationship, as you're looking for a model for this chemotherapy, you have these points and so forth, and in your proportionality model that you're using for something, you decide 1.95 is the best. That's really the best answer. Well, okay, what if we change it to 2? Well, see, that would be bad in that context because 2's bigger, and I want the least I can get because it's poisoning me. And so if one were to argue in that situation to just go with 2, again, I would say, well, no, in that situation you're wrong. Okay, because there are these other concerns outside of just this picture. And when you apply mathematics to your real life, that's what gets really hard. I mean, we're going to, in this class, use a lot of technology to make it very quick and easy to plot points, to graph lines and that sort of thing, and that way to sort of visually inspect things and kind of come up with answers. We're not going to go through all these formulaic processes and so forth, but what do we put in place of that? Well, we're trying to get you to think about how to use this sort of thing in real life and what it means to you in real life. And so in this case, for if these were our data for this project, and maybe the best answer was 1.95, and you put y equal 2x, and you showed this picture and said, hey, that looks pretty good. Oh, great, I think you've done it. You get the idea. So that's fine. But again, at times we want to go into various contexts in this course, and possibly in some context, no, the 2x won't be good enough, because you have to consider other things besides just numbers. And actually, me as a math modeler and so forth, that is the most important thing, is you need to consider all the context around you as well as the numbers. And so that's what we'll concentrate a lot on in this course. So we'll call that good for this video. I'll see if I can turn it off here, and good luck.